All right, so the last part of this section that we need to look at are combinations. So the difference between combinations and permutations is simply just order. With permutations, order matters. So if we're looking to arrange the letters A, B, C, ABC is different than BAC, right? That would be a permutation. A combination, order doesn't matter. ABC is the same as CBA, is the same as BAC, is the same as BCA. You can shuffle the order and it makes no difference as far as counting that as one thing. And so let's take a look at an example of that. So, again, like magic, in how many ways can you choose 3 books from the list? Ooh, no question mark on that? Let's go. Come on, Krieger. Question mark. There we go. Math, language, arts, history, Spanish, and physics. So you got 5 books. School has shut down. It was Friday. You're frantically trying to grab stuff. You only have room for 3 in your backpack, and these 5 are sitting in your locker. How many different ways could you choose those 3 books? Well, it doesn't matter if you grab the math book, language arts book, and then history book in that order and put them in your backpack, or if you grab the history book, the language arts book, and then the math book and put that into your backpack. Either way, your backpack contains the math book, the language arts book, and the history book. So the order in which you grab the 3 books does not matter. So if we were to list all of these out, just using the first letters, MLH is exactly the same as HLM, and that's the same as LHM, etc., etc., etc. So we have to try and get rid of all of those repeats because order does not matter. So we have a formula that will allow us to figure that out. It's very similar to our permutations formula. I'm going to go ahead and put that permutations formula back up here again, just in case you forgot. It is on a previous video, though. The permutation formula, if we have n amount of things and we're going to choose r of them, that permutation formula again was simply n factorial, look to the other video to refresh what factorial means, divided by n minus r factorial. This will tell us how many ways that we can choose those 3 objects, or 3 books in this case, if order matters. So if I plug that in, I can figure out the difference. I can figure out how many ways to order these books: math, language, arts, history, math being different, history, language, arts, math being different than that one. That's not what we want. We don't care about the order. So combinations will get rid of those repeats. And so we have the same setup with N and R, but instead of using a P, we use a C. Ironically, it's for combinations. That's not ironic at all. The formula looks very, very similar. We simply take our permutations formula of n factorial divided by n minus r factorial. That part still applies. What we need to do is we just need to divide out all of the repeats. Well, it turns out the number of repeats that we have is exactly r factorial. That's how many repeats we're going to have when we do, if we list all of these out. So we can simply plug into that formula to figure out how many ways that we could grab these 3 books from this list of 5. That would simply be a combination of 5 things choosing 3. That's how we read that. A combination of 5 choose 3. Just like before, n should be bigger than r. I can't choose it the other way around. It's got to be 5 choose 3. You can't do 3 choose 5. That's impossible. And so we just plug into the formula. It says n factorial in the numerator, so that's going to be 5 factorial up there, and then we're going to divide by 5 minus 3 factorial times 3 factorial because r is 3. And so when we work that through, we could write it all out. I want to show you how it looks. We would have 5 times 4 times 3 times 2 times 1, because that's what 5 factorial means, over in the denominator. That 5 minus 3, that's really just a 2, and so 2 factorial means 2 times 1, and then we're going to multiply by 3 factorial, which is 3 times 2 times 1. I need to change that because that was a horrible multiplication sign. There we go. You know how I am. And so now if you look at that fraction, the 3, the 2, and the 1 would reduce. That's just a 1. Who cares about that? 2 goes into 4 2 times. And so without grabbing a calculator at all, I can figure out there are 10 ways that I could grab 3 different books from this list. So let's take a look at one more example, an example that I like a lot. How many 5-card poker hands can be formed from a deck of 52 cards? We know there's 52 cards, or if we don't, now we know there are 52 cards in a standard deck. And so if you were to sit down and play poker, don't gamble, kids. Gambling's bad. Let me put that out there as a public service announcement. Gambling can be a bad thing. You got to be careful with that. But it's a lot of fun. Anyway, how many 5-card poker hands can be formed from the deck? So you deal out the cards, you get 5 cards, you look at it. How many different looks could you look at? So just for example, let's say you were lucky enough to be dealt the 10 of spades, the jack of spades, the queen, king, and ace of spades. Right? It doesn't matter what order you got those in. If you got it 10, jack, queen, king, ace, that's the same as if you got the ace first, then the king, then the queen, then the jack, then the 10, right? So this is not a permutation, because a permutation would count that differently. It doesn't matter the order that you received the cards. You're simply looking at the 5-card hand. So this would be a combination. It's a straightforward combination. We can set it up just like we did on the last one. We have our combination. We have 52 different cards that we can pick from, and of those 52, we are going to choose 5 of them. And so if we plug into our formula, what that means is we're going to have 52 factorial, and that will be over 52 minus 5 factorial, and then times 5 factorial. That 5 factorial that's tacked on there is the repeat, right? If we don't have that 5 there, this specific 5 right here, if that 5's not there, then we have a permutation, and that means that getting the ace first or getting the ace second or getting the ace third when we're dealt our hand is different. That's not the case. And so we have to have that 5 factorial there to eliminate all the other repeats. If we plug this into this formula and work it all through, you can grab your calculator and work it out. I'm just going to give you the answer, but I should probably use the right marker. There we go. And so if you work that out, the answer is 2,598,960. That's the number of poker hands that exist, not repeating anything. So that is ace of spades, king of spades, queen of spades, jack of spades, 10 of spades, regardless of what order I received those in. It's a quick formula, it's an easy formula, and using this formula, that will help us determine what we're going to be heading to next, which is probability. And we're going to look at this example again, and then we can look at what's the probability of getting 4 of a kind dealt directly to us. What's the probability of getting a pair dealt directly to us? Utilizing this total, 2,598,960, can help us get to that probability, which is where we're heading next. So, with all that said, I have homework for you. Homework, quote unquote, right? This is nothing that's for grade. You're doing this just to kind of lock in all of these ideas. So these are the problems that I found that are great problems. There are a lot of great problems in the book. Some of the problems, we're not covering everything, right? I'm just hitting the highlights. I'm just kind of trying to keep you on top of some of this math stuff as we try and navigate this whole quarantine. So work on these problems. These problems are very similar to what I went through over the past 3 videos. If you watched all 3, you should be pretty good with these. We will do something somehow depending on how much you struggle with. If you struggle, send me a remind, and depending on how many people are struggling with this, I may do a video that kind of goes through some of those problems. But otherwise, I tried to assign you, I did assign you only odd problems, since the odd problems are in the back of the book. This will allow you to look up those answers. As you're working through this, at any point in time, feel free to text me. I am at home. I am quarantined. I am following that. I hope you are too. Make sure that you're following those quarantine guidelines. So if you have any problems, issues at all, please send me a text and I will gladly go through anything that you need. Until then, stay safe, stay healthy, and until next time, have a great day.